Hey guys, Underwood here with another chemistry webcast. Today we're going to be talking about calculating the theoretical yield of a chemical reaction and finding the limiting reagent. I guess the best way to learn limiting reactant and calculating the theoretical yield is to just do an example together. So I thought that I'd give you this sample equation. We've got one molecule of methane, CH4, burning with two molecules of oxygen gas to produce one molecule of carbon dioxide and two molecules of water. We can go ahead and read the scenario here. In one experiment, a mixture of 2.50 grams of methane was burned in 1.25 grams of oxygen in a sealed steel vessel. Find the limiting reactant, if any, and calculate the theoretical yield in grams of water. So before we get ahead of ourselves, let's go ahead and talk a little bit about what limiting reactant is. The limiting reactant is the reactant that is used completely in the reaction. And because it's completely used up, it actually limits the amount of product that can be made. And so we're trying to determine, is it the methane or is it the oxygen that is going to limit the amount of water we're going to get to make in this reaction. So let's go ahead and rock through this problem here together. So we can go ahead and work this problem out together. Again, we've got methane burning in oxygen to create CO2 and water. We're given 2.5 grams of methane and we're given 1.25 grams of oxygen. Those two things react together. And we want to find out what the theoretical yield of water is, and we want to determine which one of those reactants is limiting this process. So here's where we start. I'm going to go ahead and help you outline this information. First thing, you want to go through and you want to see what you're given here. So I know I'm given 2.50 grams of methane and I'm given 1.2 grams of oxygen. And then they ask me to solve for the grams of water. We're trying to find out how much water we can produce. And so the best option here is for us to do 2 gram to gram conversion bridges, one using methane as the reactant and one using oxygen as the reactant. So that's what I'm going to go ahead and do for you here. If I go ahead, I could start with my 2.50 grams of methane. I have 2.50 grams of CH4, and that's going to be used to make a gram to gram conversion bridge. Okay, and because we've already talked about gram to gram conversion bridges, I'm not going to spend a whole lot of time on it because you guys should already know how to do it. I'm just going to show you how to use those to determine the limiting reactant and the theoretical yield. So I'll go ahead and rock through this problem here. 2.50 grams of methane. I know that 17.05 grams of methane is equal to 1 mole of methane. And I know that when I have moles of methane, I got 1 mole in a molar ratio with 2 moles of water. And now I've got to change that using my molar mass, so 1 mole of H2O, and that's equivalent to 18.02 grams of H2O. So all this good stuff cancels, we'll check this out, cancels, and look, I'm left with the units, grams of H2O. And when I do this calculation in my calculator, I end up with 5.28 grams of H2O. So go ahead and box this answer first. Okay, there's one bridge. Now, I need to do another bridge, but this time I'm going to use my 1.25 grams of oxygen. So 1.25 grams of oxygen, and I'm going to make a bridge with this, and as you can see, 16 times 2, 32.00 grams of oxygen is equivalent to 1 mole of oxygen. And now that I have moles of oxygen, I want to go ahead and and make the conversion between moles of oxygen and moles of water. So if I look at my equation, I see that there are 2 moles of oxygen for every 2 moles of H2O. And then I can go down here, and because I'm in moles of water, I want to make sure I get to grams of water, so I'll go ahead and use the same conversion as I did above. Once again, all my units cancel out. Awesome. And again, I'm left with grams of water. And when I put this through my calculator, I end up with 0.70 grams of water. Alright, well, let's go ahead and talk about what this means. So if I have 2.50 grams of methane, I can theoretically make 5.28 grams of H2O. However, I've been given 1.25 grams of oxygen, and that's all the oxygen that I get, and it turns out that when I use that much oxygen, I'm going to make 0.70 grams of water. Well, as you can see here, it is my oxygen that is limiting the amount of water I can make. So you choose the smallest one. Which reactant allowed me to make the smallest amount of product? Now that right there defines our limiting reactant. So in this case, water is our limiting reactant. Now, because this is the limiting reactant, okay, because this is the most water that we can get from the amount of reactants that we were given, then this is our calculated theoretical value. It's our theoretical yield. Okay, and the theoretical yield is the amount that we get under ideal conditions. So if we did this experiment and there was 0 air and everything went beautifully, well, we've calculated that with 1.25 grams of oxygen and 2.50 grams of methane, we can make 0.70 grams of water. Okay, and that is our theoretical yield. Okay, awesome. Now, this is very similar to what we're going to be asking you to do on the worksheets in class. So I want you to go ahead, watch this video, get some questions together. If you need any extra help, just go ahead, come into class. We'd be happy to answer any questions you might have. This is Underwood, signing off. Oh, and before I sign off, I have to say that you need to watch the next video because I'm going to be discussing percent yield and percent error, and I'm going to be using this example once again. All right, good. So this is Underwood saying goodbye.